Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we'll be talking about multi-stage amplifiers that we can make using MOSFET, same as the case with BJT. In BJT I told you about multi-stage amplifiers. In that we covered 3 configuration: Cascade, Cascode and Darlington pair. But in MOSFET we'll only focus on one configuration, that is the Cascode configuration. So for that we will first understand common gate amplifier but with an active load. Active load means the load resistance is not a passive resistance RL, but the load resistance is another transistor and the transistor is an active device. Why I am doing this is, if you remember in multi-stage amplifier what happens? The output of one transistor is acting as the input to the other transistor. That means transistor itself acts as a load on the other transistor. And if that is happening, I can say that the load of the transistor is active in nature. So that is what I am saying here, that we will consider common gate amplifier with an active natured load, or you can say the load of the common gate amplifier will itself be a transistor which might be connected in some other configuration. Now before doing that, first of all what I want to do is, I want to study the effect of body terminal on MOSFET. So we want to understand about body effect on amplifier. Okay. Now what happens? Usually source and body are shorted together. Most of the times the source and the body are shorted, but if voltage is applied at body terminal, okay, if we apply the voltage at body terminal, then what will happen? Then electric field changes. If electric field changes, the voltage required for inversion, also changes. So we can say threshold voltage changes. I told you the gate voltage at which the device gets inverted or it operates in the inversion mode is called as the threshold voltage. So that also will change if you change the body voltage. Is it fine? Now, we know that in saturation region, MOSFET works as an amplifier in saturation region. In saturation region, the drain current is proportional to VGS minus VT square. So change in VT will also cause change in ID. If ID changes, remember we defined a transconductance as del ID by del VGS. Similarly, I can define another transconductance GMB del ID by del VT. Because ID will also change with threshold voltage, it is called as body transconductance. Okay, that is transconductance with respect to the varied body potential. So GMB is transconductance by varying body potential. Okay, So that transconductance is called as GMB. Now based on these two transconductances, I can modify the T model that we studied for the MOSFET. I told you about two models, hybrid pi model and T model. In T model, what we did is, there was a gate terminal, then there was a resistance between gate and source. This is gate, this is source. Then there was a current source. Then there was an output resistance. Okay. Now, this was the drain terminal. Earlier I told this resistance is 1 by GM. This voltage is VGS. And this current source was GM VGS. The current here is 0 ampere. Now we have two transconductances. Which two transconductances are there? First transconductance is GM, the other one is GMB. Are you understanding where does this GMB come from? By varying the body voltage, we can vary the threshold voltage, which will affect the drain current, and it is represented by the transconductance GMB. Now, if you see the figure on the right, the gate is connected to ground and the body is also connected to ground. If G and B are connected together, then you can say that VGS is actually equal to VBS. So I'll say VGS equal to VBS equal to V. So that is why this source now I will modify. I will cause there will be two currents due to two transconductances, that is into V. And this will also be a combination of two transconductances GM and GMB. So what I have done is, I have increased the effective transconductance. The effective transconductance is actually the sum of two transconductances, which is GM and GMB. And in this figure, since both the terminals are grounded, I will ground this gate terminal. Okay. Now let me modify this circuit. Gate terminal is grounded, so I am grounding the gate terminal. But in this figure, if you see, RS is connected to the source, and this RS has a voltage Vs behind it, like this. Okay. So that will be the overall model of the circuit when we are drawing this circuit. And also, if you have a load connected at the drain terminal, you can also show that load. If you have a load, that load can be represented as RL. What I mean to say here is, if there is a load connected at this terminal, that can also be shown in the circuit as RL. Okay. Is this circuit fine? Now I want to find certain parameters of this circuit. So let us move on and find the parameters one by one. First of all, I want to find the input resistance. Okay. My first aim is finding the input resistance. So input resistance is represented by Ri, but always remember, ignore source resistance. Okay, we will never consider the source resistance. So now see, we want to find the input resistance, which means I want to find the ratio of voltage after the source resistance and the source current. Why I am not taking Vs? Because if I take Vs upon Is, then this Rs will also be included. So I'll say Ri is Vi upon Is. Now I will define some currents here, suppose I1 and suppose I2. Okay. and this current will then be, suppose this is V0 minus I1 plus I2. Okay, that will be this current. Now applying KCL at this node, suppose I apply KCL at this node, so what I will say, IS is minus I1 minus I2. Now if I want to find I1, the voltage at this terminal is V0 and the voltage at lower terminal is Vi. So I will say I1 is V0 minus Vi by RD. What about I2? The voltage at this terminal is ground, that is 0. The voltage at this terminal is Vi. So 0 minus Vi by 1 over Gm plus GmB. So it will be minus Gm plus GmB Vi. Okay. So now that means if you substitute this value, it will be Vi minus V0 by RD plus GmVi plus GmB Vi. Now what I want is Vi by Is. So I want to remove this V0. Now what is V0? Minus of I1 plus I2 into RL. Minus I1 plus I2 into RL. Now minus I1 minus I2 is Is. So it is Is into RL. So Is is Vi 1 by RD plus Gm plus GmB minus Is RL by RD. Which means if you take Vi over Is, it will be 1 plus RL over RD divided by 1 by RD plus Gm plus GmB. So that will be the input resistance Ri. Okay, that is the first parameter that I wanted to find, is the input resistance. The next parameter that I will be deriving for you guys is the voltage gain. Okay, voltage gain. So we know voltage gain is V0 by Vs. V0 I just now in the previous derivation I wrote Is into RL. What about Vs? Vs, if you apply KVL, what you can do is Vs is Vi plus Is Rs. Vi plus Is Rs. Now Vi is Is Ri plus Is Rs, which means Vs is Is Ri plus Rs. So if you want to find the voltage gain, it will be RL over Ri plus Rs. Okay, RL by Rs plus, what was Ri? RL by RD, 1 by RD plus Gm plus GmB. Okay, that is your voltage gain AVS. AVS, or you can say AV. AVS is basically V0 by Vs. Now if you want to find open circuit voltage gain, open circuit voltage gain. Open circuit voltage gain means the output is open circuited or RL tends to infinity. So you can divide the whole equation by RL. You can write it like this: Rs by RL 1 by RD over 1 by RD plus Gm plus GmB. Now in this case, if you take RL tending to infinity, it will become, this term will go to 0, Rs by RL, and the denominator will now become numerator. or you can say 1 plus GM plus GMB into RD. So that will become the overall voltage gain, but under the condition of open circuit. Next, the last parameter that I want to derive is the output resistance. Now this output resistance is V0 by I0. But when do we take this? When your source voltage is 0. So let me redraw the circuit that we draw earlier. We had a source resistance Rs, but I will keep supply voltage as 0. At this point, this was the source terminal. We had a resistance 1 by GM plus GMB. The gate was grounded. Then we have a current source GM plus GMB into V, or you can say VGS. Between drain and source we had a resistance R0. Now while calculating output resistance or RD, while calculating output resistance we don't take the load resistance RL. So I want V0 over I0. Now I0, as you can see by KCL, I0 is sum of two currents. I0 is equal to actually I plus GM plus GMB into VGS. Now this voltage is VGS. Now gate is connected to ground. Suppose the voltage of this terminal is V. So I0 is actually I minus, or sorry, plus GM plus GMB. How you will write VGS? 0 minus V. Okay, that is your VGS. Now what you can do is, the current going here, suppose I1. What is this I1? Simply V by RS. Now this I1 is actually sum of two currents. It is I plus GM plus GMB VGS. So I1 means V by RS. I'll write here. I1 means V by RS is equal to I plus GM plus GMB VGS. VGS is minus V. So I will write minus GM plus GMB into V. So V 1 by RS plus GM plus GMB is equal to I. Now I know the value of I in terms of V. So what I can do is, I can find out I0. I0 will be I is this one, V into 1 by RS plus GM plus GMB minus GM plus GMB into V. This term will get cancelled. So I0 is simply V by RS. I know the value of I0, but I want the value of V0. So how you will find out the value of V0? We have the value of I0, but we want the value of V0 in terms of I0. Now V0 is simply, if you apply KVL like this, V plus I RD. Now I know the value of I in terms of V. I in terms of V is 1 by RS, so it will become RD by RS plus GM plus GMB into RD. Now if you take V0 by I0, If you take V0 by I0, we will get cancelled out. So it will be RS plus RD plus RDRS GM plus GMB. So that will be the value of output resistance. Is it fine? So that parameter also can be derived, but always remember the basic definition of parameter. Then if you can draw the circuit, you can derive any parameter for any transistor. Now, when we talk about common gate configuration, why is it special? In common gate, what happens? In common gate, the input is applied at the source terminal and output is taken at the drain terminal. Now I very well know in a MOSFET that the source current is equal to drain current. If that thing is happening, I can say that this common gate configuration is working as a current buffer. Buffer means which passes the same value further. So it is passing the source current at the output. So it is working as a current buffer. Also, common gate configuration. Common gate configuration increases the output resistance and decreases the input resistance. And how is that helpful? See, in a current amplifier or current buffer, what happens? The circuit model is like this. I'll show you these models again also later on. I am showing you the model of a current amplifier. This is input resistance of the amplifier. This is input current. The output current of amplifier is AI into II. Okay. Then this is R0. This is RL. And that is the final output current IL. Now I want IL to be as high as possible. Or you can say IL over IS should be high. Now I know only II is going further. So this II should be high. II can be written as IS into RS by RS plus RI. It is equal to IS, but when Ri is 0. That means if this branch was shorted, the entire current will go as II. So ideally, input resistance should be as small as possible for a current amplifier so that maximum current enters the amplifier. Now similarly, you can write IL as AI into II, that is a current source, and by current division R0 by R0 plus RL. So it is also equal to AI into II, but when R0 is infinity. That means if you open circuit this resistance, the entire current will go into the load. So for an ideal current amplifier, the input resistance must be 0 and the output resistance should be infinite. That is why it is always desirable in a current amplifier that input resistance should be as low as possible and output resistance should be as high as possible. These are the desirable characteristics of a current amplifier. Now, once we have a common gate amplifier, we will use this common gate in one of the configuration that we call as Cascode. Now in BJT, this Cascode connection was also called as common emitter and common base configuration. We were using two configuration, one was common emitter, other was common base. Now here emitter is replaced by source and base is replaced by gate. So we will call it as common source, common gate configuration. See, the first transistor is connected as common source, okay, where input is connected at the gate and output is taken at the drain. Now this output is working as an input to the second transistor. It is the input of the second transistor. and input is connected at the source and again output is taken at the drain. So gate is common. So this is common gate. So Q1 is connected in common source configuration because input is at gate and output is at drain, and Q2 is connected in common gate configuration. So that is why Cascode connection is nothing but it is connection of common source, common gate configuration. Okay. Now what happens? See, the output resistance of one configuration will work as an input of the second configuration. See, the output, what I mean to say here is, listen this carefully, the output of Q1 is input of Q2, right? Because whatever we obtain output from Q1, that is fed to Q2. So can I say this? R02 acts as input to Q2. Sorry, R01. Is it fine? So what we will do is, we will replace the entire first transistor by a resistor when we are analyzing the second transistor. So let us see how we can draw the model. Okay. So let me first remove this. Then I will show you how to draw the model. Okay. So what I have said is, we will replace the first transistor by a resistor. Okay. So this is the source terminal of Q2. It is connected to a resistor that I am drawing here, R01. Now between gate and source we will have a voltage VGS, and between drain and source we will have a current source GM VGS. Okay. In parallel with this current source, we will have the output resistance of second transistor, that is R02, and this voltage will be V0. Okay. Now this is a DC voltage. When we are doing AC analysis, we ground the DC voltage. So we will ground this terminal. Now what I need to do is, I need to find the output resistance of this configuration. If you want to find the output resistance of this configuration, R0. So R0 is nothing but V0 by I0. Okay. Let us try and derive this value V0 by I0. I0 will contain two currents, GM VGS, and this second current I. So I0 contains two currents, GM VGS plus I, and these two currents are adding up and going here. So if I apply KVL like this, so what I will say, 0 minus VGS minus I0 R01 equal to 0. So VGS is minus I0 R01. Okay. And what about I? VGS is minus I0 R01. But I also want the value of V0. For V0, what I will do is, I will apply KVL like this. Okay. But before that, I need to find the value of I. That I can find from this equation. I0 is GM VGS. VGS I will write minus I0 R01 plus I. So I is I0 1 plus GM R01. Once I have this value, I can write V0 as I into R02 plus I0 into R01. I into R02 will become I naught R naught 2. I am putting this value of I plus I naught GM R naught 1 R naught 2 plus I naught R naught 1. Now if you take the ratio V naught by I naught, it will be R naught 1 plus R naught 2 plus GM R naught 1 R naught 2. So that is the overall output resistance, and its value comes out to be approximately GM R naught 1 R naught 2. Remember, this is transconductance of Q2, that is the second transistor. Okay, so you sometimes we also write it like this, GM2 R naught 1 R naught 2. If you get confused, Q2 is the transistor where output is connected. Okay, so Q2 is the transistor where your output is connected, and at that transistor the output resistance is GM2 R naught 1 R naught 2. Okay, now what about the transconductance, overall transconductance, if I ask? How to find this overall transconductance? The overall transconductance is del I out by del Vi. Now output current is this current. In a MOSFET, the drain and the source currents are same. If the drain and the source currents are same, this current is also I out. So for this transistor, the drain current is I out and gate to source voltage VGS is Vi. So what I will say, for Q1, drain current is I out and VGS is Vi. We know the transconductance of any transistor is the ratio of change in drain current to change in VGS. So that is del I out by del Vi. So that is also GM. So GM is equal to GM1. That is the overall transconductance is same as the transconductance of the first transistor connected to the supply. So remember, when we are finding the output resistance, we are using transconductance of the second transistor which is connected to load, and when we are finding transconductance, then we are using transconductance of the transistor near the source. The last parameter that we want to find is the voltage gain. The voltage gain of an overall transistor is minus GM R naught. Now this GM is GM1 because I told overall transconductance is GM1, and overall R naught is GM2 R naught 1 R naught 2. So it is equal to minus GM1 GM2 R naught 1 R naught 2, or you can say minus GM1 into R naught 1 and GM2 into R naught 2. Okay, that is the basically product of voltage gain of both the transistors. So it is very simple if you can draw the model, but in Cascode connection, just remember one thing: the first transistor will be modeled as a resistance for the second transistor. As simple as that. Now this can also be designed using CMOS. What is this CMOS actually? CMOS is complementary MOS. Complementary MOS means it uses two types of complementary transistor, PMOS and NMOS. So the device implemented using PMOS and NMOS is called as CMOS or complementary MOS. So see how we can design Cascode connection using complementary MOS. So this is a PMOS transistor, another PMOS. That is, I am designing Cascode using PMOS. Now I will design Cascode using NMOS. Okay. This is suppose output voltage, and we have 4 gate voltages VG4, VG3, VG2 and VG1. Okay, this is Q1, Q2, Q3, Q4. So I told you, what did I told you? When you want to find the output resistance of suppose NMOS transistors, in NMOS transistor, which transconductance you will use? The transconductance of the transistor near to the output, which is near Q2, transconductance GM2 into R01, R02. What about PMOS? Which transistor is near to the output? Q3. So GM3, R03, R04. So these are the output resistances. What about overall transconductance? That is the transconductance of the transistor where input is connected. GM1, because input will be connected at Q1. Okay. What about overall output resistance? It is parallel combination of R0N and R0P. Because if this is VDD, when you will ground this VDD, these two branches of PMOS and NMOS will be connected in parallel, and overall voltage gain is minus GM R0. Remember this, whenever these two branches are connected, both PMOS and NMOS, then at the time of AC analysis, both will come in parallel, so their output resistances will be in parallel. So let me summarize what I have covered in this video. For modeling body effect in amplifier, we define a current source which is GMB, VBS. VBS is body to source voltage. So we have one more transconductance in order to define the body effect. Then I told you about common gate amplifier with body biasing, means whose body was not connected to source, or you can say VBS is not equal to 0. Then we saw Cascode connection. In Cascode, what you have to remember? Q1 modeled as R0 for Q2. In this we saw the transconductance overall was equal to transconductance of the first transistor, and overall output resistance was transconductance of second and output resistance of the both first and second. So that is what we have covered in this video. In the next lecture, what I'll do is I'll tell you about the problems that are based on MOSFET amplifier, both single stage and multi-stage. Okay, so that will be all from this video. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these two channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.